Good day, everyone, and welcome to another problem-solving session with Special Maths Academy. So today, we'll be looking at the next geometry problem in the series, and that is problem 32 from the just concluded Nigerian Mathematics Olympiad for the senior category, first round, 2020. So let's look at the question. So tiles of shapes A and B are available in various sizes. Which of the following shapes cannot be achieved no matter how many tiles are available? Okay, so the first one seems pretty easy because we can quickly find an example that shows that a rhombus can be achieved. So once you merge two isosceles triangles by their bases, you are going to get a rhombus. You can achieve. So if we merge, let's say for instance tile B, so this is 36 degrees, 36 degrees, 36 degrees, 36 degrees. So we see that we can achieve tile A. Okay, so let's look at tile B. So tile B, we have a cyclic quadrilateral with 3 consecutive sides equal. Okay, so 3 sides equal because any 3 sides will form the consecutive sides in the quadrilateral. And so the question is, how can we form this using these 2 tiles? So what are the things you know about cyclic quadrilaterals? First of all, let's complete the angles in these tiles. So since this is isosceles, it means these 2 angles will be equal here, and they'll be equal to 72 degrees. So we can quickly do sum of angles in a triangle being 180 degrees, and then finding the 2 base angles. And then since this is also isosceles, it means the base angles are equal. So this angle will be equal to the already given 36 degrees. And then the third angle is going to be 108 degrees. We can quickly get that from sum of angles in a triangle being 180 degrees. So it means any shape we form from our tile, from our set of tiles, the angles at the vertices must be sums of angles from this set. So all the angles at the vertices must be of the form, say 36m plus 72n plus 108k, where m, n, k members of integers. Okay, so now how do we get a shape like this? So to get this, we see now which angle, in what ways can we sum 2 angles from this set to get 180 degrees? Because we have that this angle and this angle sum up to 180 degrees. So you see that the only way we can do that is to go with 72 and 108 degrees. So we begin to build a tile. Okay, so we break this cyclic quadrilateral into 2 triangles, and we claim that if we have this to be 36 degrees, this to be 36 degrees, so I'll just erase this. So this is equal to this, and this is 36 degrees, and this is this whole angle here is 36 plus 72, which is equal to 108. So we have that this is cyclic. So now we want this third side to be equal to these other 2 sides. Now, since we've established that this quadrilateral is cyclic, it means we can begin to play around and use circle theorems. So this angle here is going to be 36 degrees too. Why? Angles in the same, subtended by the same chord. Okay, Now, since this angle is 36 degrees, so let's look at this triangle here. So let me draw this diagram better. So we've established that this angle here is 36 plus 72, which is equal to 108 degrees. And we got this angle here to be 36 degrees from angles subtended by the same chord. So we can, and we have that this side here is equal to this side. So now we can quickly get this third angle in this triangle. So I have 108 plus 36, and then we subtract it from 180 degrees. And we get, surprisingly, 36 degrees again. So it means this angle here is 36 degrees. So we can conclude that this is also isosceles. So in fact, this is side length is equal to this side length. So this is equal to this side. Okay. So we can see that we can form a tile of shape B. Now we look at option C, and we see that we have a kite. Now what are the properties of a kite? A kite has two pairs of adjacent sides equal, and then a pair of opposite angles equal. And the opposite angle being that are equal are, formed by different sides from the two pairs of adjacent angles, so which I'll just depict here. Okay, so for the two opposite angles to be equal, and the kites to also be cyclic, you must satisfy properties of kite and cyclic quadrilateral. So we have alpha plus alpha. So if we say the two opposite angles are equal, alpha and alpha. So we must satisfy that alpha is equal to alpha, and then alpha plus alpha equals to 180 degrees. And what do we have? We have alpha is equal to 90 degrees. Now we see that 90 degrees is not of the form 36m plus 72kn plus 108k. Okay, for m, n, and k being integers. So we see that this is not possible. Option C is not possible. So actually, the answer is option C. But let's just go around and see how we can get D and the others. So now to get option D, we will need to form two parallelograms. So we need to form, first of all, I'll just erase some things here. So I won't explain the processes I used to form, option D and option E. I'll leave that for you to figure out. So I won't really explain the process I took to get to it. So for option D, we can form a parallelogram, or let's say a rhombus. So with tile B, okay, so this is tile B, so this is 36 degrees. Okay, so this is a rhombus. Okay, so this is tile B. And then since we have this angle here to be 108 degrees, so we need another 108 degrees. And then, so we need to get here to be 36. So we use tile A size of tile A such that this length here is equal to this, and then we form another parallelogram. So sorry about that. So you erase this, okay? So we form another parallelogram, or rhombus rather. So this is tile B, and this is tile A. So this angle here is also 36 degrees, and we know that 36 plus 36 plus 36 will give us 108. So in fact, this whole angle here is equal to this angle as we want in the diagram. Okay, and we see that we can, since this is these are rhombuses. Since these are rhombuses, we have that this line is parallel to this line. This line is parallel to this line, and we can get this angle here. This angle will be 36 plus 36, from this angle here, this rhombus, and then this other angle here will just be 36. So we have, in fact, this angle here also being equal to 108 degrees. So I just showed that we can form this shape. From the tiles. So let me just erase this. 108, 108, 108. Okay. Now, but we have that, this is not necessarily being equal to this other side. So we see that if we, continue fixing same tiles, since this angle here is equal to this angle, it means they can interlock perfectly. Since this angle is equal to this angle and this side length is equal to this side length, so they can interlock perfectly. So you can keep on fixing, to get this option D to be possible. Okay. And since the way we formed it, it's by the way it's formed by the tiles A and tiles B, it's split into two rhombuses. So we have, in fact, that this line is parallel to this line. So it means they can perfectly align to form tile D. And then for tile E, we can extend this side length here. So I'll just erase this. And this here is 36 degrees, 36 degrees. So let's call this from here, this base, the base of this tile A here, Y, and from here to here, X. So we want to show that from here to here it's X plus Y. Okay. So I'll just check to see that I typed the question correctly. Okay, yeah. So in the question, it's actually given that this side length here should be Y. So sorry about that, I didn't show that. So it's actually given that from here to here should be Y. So to show that we can form this, so I'll just erase this. We bring tile B. So let from here to here be Y. And then we construct an isosceles triangle. So this is tile B, this is 36. So it means this is also Y. And this is 36. So this is tile B. And then we mark out point Y here. And then let's call this remaining part X. So since this is also the isosceles here, it means this triangle here I just brought in is congruent to tile A. Although it's not a tile, but the triangle is congruent to the triangle formed by tile A, so it's not a tile, so take note of that. Okay, so if we construct then we attach a tile A that has a base of length Y. So this is 36 here. Okay. So to show that this length here is equal to X plus Y, how do we do that? So one quick thing we can see is that we can try to construct, congruent triangles. Okay, so this is 72 here, this is 72 here, and we made this out to be Y. Okay, so if we mark out the angle bisector here, Okay, so let me just mark this out. So the angle bisector, since this is tile B, so we got the angle bisector here will split this to 36, 36. Okay, so this angle here is 36, but we see that this angle here is also 36. So in fact, this is isosceles here. This triangle here is isosceles. Okay, so it means this is going to be y. Okay, but we already so now we look at this angle here. Since this is tile B, and we marked out this angle here to be 72. So we take away 72 from 108. So it means this angle here is 36 degrees. And this is also isosceles. Okay, so it means this base here is x, and since this base here is x, and we just duplicated this triangle here again, so it means this base here is also x. Okay, so we see how we can form it. So I'll just erase some things here so to show how this can be formed. Okay, so look at it in the 72, 72, angle bisector 36, 72, 36. So x, x, y, y. Okay. So this is how we can get a tile of type E. So our answer is option C. Okay, and we'll stop here for today. See you in the next video.